All right, so if you've spent any time at all with older Allen Bradley gear, you've definitely run into this puzzle. RSLogix 5 and RSLogix 500. I mean, look at them. They've got the same gray menus, the same ladder editor. They feel exactly the same. It is so easy to mix these two up. So today, let's finally clear the air and figure this out for good.
Right? That's the million-dollar question. You pop one open, then the other, and you're sitting there thinking, wait a minute, this is the exact same program. But spoiler alert, they're not. And trust me, knowing the difference isn't just for trivia night. It's absolutely crucial if you're out in the field trying to program or troubleshoot these systems, which, believe it or not, are still everywhere. Probably the easiest way to wrap your head around this is to picture an old, dusty toolbox. You reach in, you pull out two wrenches that look, they're practically twins. But then you realize they're for totally different jobs. Well, that is RSLogix 5 and 500 in a nutshell. They came from the same family, same design, but they were built for completely different machines. And boom, here it is. This is the single most important thing to remember. RSLogix 5? That is only for the big dogs, the heavy-duty, chassis-based PLC-5 platform. We're talking massive, complex factory lines. Now, RSLogix 500, that's your go-to for the little guys, the much more common SLC 500 and MicroLogix controllers, for your everyday small to medium-sized machines. So yeah, same look, completely different targets.
Okay, so before we dive deep into all the nitty-gritty differences, let's just take a second to talk about why they feel so much alike. Because they do. And the good news is, if you know one, you pretty much know the other. Your skills are totally transferable because, well, they really do share the same DNA. And you can see that family resemblance right here. The user interface, the menus, the icons, how you get around, it's practically a carbon copy. The heart of the programming is good old ladder logic, of course, and they both use that, let's call it vintage, file-based memory system. With the classic N7 for your integers, B3 for your bits. That's a whole different universe from the tag-based world we live in now with Studio 5000. And yeah, let's be real, they're both definitely considered legacy software at this point. All right, now that we've got that straight, let's get to the juicy part, the heart of it all. These are the subtle but absolutely critical differences that you really need to burn into your brain, because these are the little details that will absolutely get you into trouble out on the factory floor. So this table here is going to be our roadmap for the next few minutes. We're going to break down 3 key areas where these two platforms really go their separate ways: I/O addressing, how they deal with analog values, and a few little quirks in their instruction sets. First on the list, I/O addressing. Oh man, this one is a classic. It's tripped up so many people. See, RSLogix 500 is straightforward. It uses the decimal, base 10 system we all learned in grade school. Bits are numbered 0 all the way to 15. Easy. But RSLogix 5 for the PLC 5 throws a curveball. It uses an octal system, which is base 8. So what does that mean? It means the bits go 0, 1, 2, 3, 4, 5, 6, 7, and then bam, it jumps to 10. There is no bit 8 or 9. I'm telling you, if you don't know that's coming, you will lose your mind trying to find bit 8. Next up, how they handle analog signals. In RSLogix 5, it's a bit of work. You have to use these special instructions, BTR and BTW, that's block, transfer, read, and write, to literally drag the data from the analog card into the PLC's memory. It's a very clunky manual process. RSLogix 500, on the other hand, is so much friendlier. A lot of times, the analog data just shows up where you need it. And even better, it has this awesome instruction called Scale with Parameters, or SCP. It lets you convert those raw analog counts into real-world units, like PSI or temperature, right there in one line of code. Super convenient. Okay, everybody, listen up. We're about to talk about what is, without a doubt, the single most dangerous trap waiting for you inside a PLC-5. I'm not kidding. This isn't just some weird little quirk. This is something that can and absolutely will crash your processor and shut down your entire production line if you don't see it coming. Say hello to this number, 32,767. You need to burn this number into your memory. Why? Because in the 16-bit world of a PLC-5 integer, that's the ceiling. That is the highest positive number you can possibly count to. One number higher, and everything breaks. You get what's called an overflow. And if you're counting parts or using a high-res encoder, you're going to smash through that limit in no time flat. So why is this even a thing? Well, it all goes back to the hardware. The PLC-5 is a true 16-bit processor. It doesn't have a built-in data type for a big 32-bit number, what we call a dint or a double integer in the modern world. Its brain is wired to think in 16-bit chunks. That's it. So if you need to count higher than 32,767, you've got to find a workaround.
And the classic workaround is something we call two-word math. It seems pretty clever, right? You take your big 32-bit number and you basically chop it in half. You store one half in one 16-bit integer, the least significant word, and the other half in another, the most significant word. Then you use a simple math formula to stitch them back together into a floating point number that can hold the big value. Seems perfectly logical, doesn't it? And here's where it all goes wrong. This is the trap. You write that code, it looks perfect, you download it, and the very instant the PLC tries to do that math, specifically that first part, the multiplication, the result of that calculation blows past 32,767, and bam, the processor faults, you get a flashing red light, a major error, and your whole machine just dies. Okay, deep breaths. So how do we actually do this safely? How do we handle big numbers without crashing the whole plant? The good news is the fix is actually incredibly simple, but you have to know what it is, and even more important, you have to know exactly where to put it in your code. Behold, the magic rung. This little line of code is your get-out-of-jail-free card. It's just an always-on instruction that unlatches one specific bit, S:5/0. Now, what is that? That is the math overflow trap bit. See, when the math goes wrong, the PLC flips that bit on. Then, at the very end of the scan, it looks at that bit. If it's on, it crashes. So our entire job is to just flip that bit back off before the processor has a chance to check it. But here's a super important piece of advice, something you learn from experience. Think of that rung as a seatbelt. It will save you from the crash, for sure. But it does not fix your math. The final number you calculated, it's still going to be garbage because the overflow still happened internally. The number rolled over. All you did was tell the processor, hey, don't freak out about it. So to actually get this right, to prevent the crash and get the correct answer, there are two rules you have to follow, no exceptions. Rule number 1, that magic unlatch rung for S:5/0, it has to be the very last thing in your main program, which is almost always ladder file 2. If you put it anywhere else, it won't work. Rule number 2, to make sure your final answer is actually correct, the destination for your calculation has to be a floating point register, an F8 file. That's the only data type with enough room to hold the big number accurately. You know, it's easy to dismiss these systems as legacy, but the truth is they are still absolute workhorses. There are thousands and thousands of PLC 5s and SLC 500s out there right now running really important stuff all over the world. So knowing these little personality quirks isn't just trivia, it's a critical skill to have. And that really brings us back to our toolbox analogy, which I think sums it all up perfectly. RSLogix 5 for the PLC 5. That is your big, heavy-duty, industrial-grade pipe wrench. It's for the huge, complex jobs. And RSLogix 500? That's your versatile socket set. It's got everything you need for the 99% of small and medium-sized jobs you're going to run into every day. They're just two different tools from the same toolbox. So there you have it, the tale of two Logix. You know, learning about that 16-bit math trap is one of those classic lessons learned the hard way out in the field. And it kind of makes you think, doesn't it? What other little quirks, what other hidden gotchas are buried in these old systems, just waiting for the next person to stumble upon them?